Hi, everyone. We live in a networked world, and the internet has changed the way that we network and connect to things, and it's changing the way we network every single day. People are connected to people, places, data, topics, and all of that is translated into imagery, to visuals, to motion, to text, and to things. So what I want to talk to you today about is the next big thing of 3D things, the Internet of Things, and why I think that the main technology that will drive the way we impact our networking of 3D things is a technology that's cited to cause the next industrial revolution, and that manufacturing technology is known as 3D printing. So you've had 3D printing introduced to you, so I might be covering over topics, apologies if I do, but I want to tell you about how this technology really works. We're all familiar with inkjet printers. We download our data from our Excel sheets, our Word documents, and we send that two-dimensional data to a machine that's fed with ink, and out comes an image. Well, 3D printing borrows the name from the same sort of concept, although it kind of puts us off a bit. Just like we feed two-dimensional data to an inkjet printer, we feed 3D data to a 3D printer, along with material. And that material can be plastics, metals, ceramics, glass, anything that can be melted, chocolate, sugars. This is a 3D printer by HP. And you can see today you can fabricate items on your desktop. How do they work? For those of you who don't know, they read CAD data, three-dimensional data. This is created in professional product design software and passed through to the 3D printer, where the data is sliced from three-dimensional data to two-dimensional data of a product, just as you can see the cross-sections here. And those cross-sections are passed to a machine. In this case, this is an EOS laser sintering machine, which deposits a layer of material. Unfortunately, you can't see the video, but you'll have to take my word for it. It takes the data, and it will use lasers within the machine to fuse new layers of material to old layers. And in this case, we have a powdered material that's fed through to the 3D printer. And over time, we call it rapid manufacturing, a three-dimensional object is formed. So we call this technology of the industry additive manufacturing. It's more commonly referred to as 3D printing. Well, I'll skip this, because unfortunately it doesn't work. It's a remarkable process. It's very quick. It's been maturing over 25 years now. And we can make structures in a variety of different machines in a variety of different ways. A very large machine called the D-Shape created this structure with layer thicknesses of 5 millimeters. And this structure was about 2 meters in height. Very remarkable. And on the other end of the spectrum, this is an EOS laser sintering machine that has created microstructures as small as the ones that you see here on the screen. Their layer thickness is about 4 microns. And really, we're finding this technology to have advanced so much now that we're not just using it for the hobbyist market. We're using it for luxury, high-end, high-level engineering components. And we're really managing to use the complexities of the technology to advance products that cannot be built in any other way. So 3D printing really does, in some cases, challenge mass production. To me, what I'm very interested about is taking this three-dimensional data and using it to produce runs as little as one. So mass customization, as this technology is very rapid, you don't really have any economies of scale, so to speak. And we can really use this technology to optimize components, to individualize, to customize. And this is data from a pair of cufflinks. And you can see we've added some initials. and then passed that to an EOS laser sintering machine, where we've built them in titanium. And we also 3D printed the box separately in another machine. It's made out of a polyamide plastic. And I had so much fun when we were designing this on a bit of software that I decided to personalize it and give a few away to some friends. That's how easy it is to create runs of one. And this could revolutionize products today and the way that we interact with things. And the materials are so vast. They're ranging from plastics and semi-precious metals all the way through to precious metals. So here we had to go with the help of Cookson PLC in association with EOS laser sintering to produce the same cufflinks in gold. They came off the machine, as you can see, quite rough, but when they were polished down, we've got beautiful structures that challenge craftsmanship, and the quality is just as good as the things that you see on the market today. Again, another beautifully designed object. This is designed by a pioneer in 3D printing design called Lionel Dean. He's created a very intricate necklace in gold, again. And you can see how intertwined this design is. It's really important to understand that you can create complexities. Anything that you can model in 3D, you can create, which is not the case with standard manufacturing, because in most cases, we're limited to injection molding. We're limited to time factors, or if something's done by hand, we're limited to the craftsmanship of the individual who's making it. 3D printing does away with these limitations for the most part. And we can do away with high injection molding costs, where a design is sent off to China. It could be iterated through injection molding and incur potentially tens or hundreds of thousands of pounds worth of cost. With a 3D printer, you can iterate the design very quickly, prototype them, and again, as I mentioned, use this technology for mass customization. And we're talking about products to market within days now. So we are abolishing a need for warehousing, no need for stocks. In fact, if we digitalize everything, we could be selling products before selling products before we even make them. So the positive cash flow is quite remarkable. And what my company loves about 3D printing is the idea that you can mass customize, as I said before. We've seen every company in the market today moving down the direction of customization. People want to interact with products on their own terms. You can customize everything from your car to your sunglasses, your jewelry. The list goes on. And the way we interact with products now is moving towards three-dimensional modification or iteration. We can see sites like Shapewaves emerging, Sculptio, where you can really engage with the product in 3D. Now, what my company does is assist other businesses to implement mass customization, to really exploit 3D printing technologies and help their customers get the product that they want. Again, I'm sorry the video doesn't seem to be working, but it allows for a modification in 3D. But we allow the co-designer to work on a base product that they've designed, and when they're ready, they output the design to the 3D printer through a network. We don't manufacture goods. We pass on to third parties. We are simply a platform for co-design to enable mass customization. And here is the lamp that was customized in 3D. It was designed by our creative director, Asa Shuash, and he opened it up through our software, our co-design platform, for modification by third parties. But he set the constraints within our software for the individual to work within. Because as we know, individuals don't know how to design in 3D, don't know how to create functional products. So it's important that they have a means of interacting with a 3D printer on their own terms, but without going to the realms of creating something that may not be buildable or functional or have fit for use, or perhaps even be aesthetically pleasing. And really, we can create, using a software like this, an infinite number of permutations. Now, what digital forming's been working on is this co-design platform where we could create an interface between the designer and the user or co-designer who has no knowledge of 3D design and connect them to the 3D print manufacturer who have all kinds of rules for 3D printing. Now, the designer is the CAD creator. This is our designer, Ricardo, in our studio in London. And he sketched a design, and then using a professional program, he mocked it up, like SolidWorks, for example. And he's then imported that into software that we have recently created that will be launched in 2 months, where he's creating the customization experience for his clients. And this could be used by a brand, any design company or designer. And he's saying, OK, well, I'm going to allow that customer to interact with the product, stretch it out of shape, but I'm now setting the limits of that customization. He's saying that it's going to be available in certain materials, in certain colors. He's specifying everything to do with how that product can be modified by the consumer. He's adding in library of parts that could be handles or the tops of the different mug. He's created these all in pre-existing professional design packages. And once he's happy with his customization experience and the limits he's set, that all gets packaged up, uploaded to his website, and made available for a co-designer. And we really wanted to empower the co-designer to create things that weren't just simple hobbyist-type products. We wanted to empower them to make very high-end design products. And the only way that we could do this was this two-way interface. So once the designer has uploaded his product with his constraints onto his branded website very easily, almost like a content management system, then the user has a very simple way of iterating that design and creating a customized product. And it's not just limited to shape manipulation. It could include adding text, embossing images, all kinds of things. But we wanted to empower designers to now use 3D printing in such a way. I'm glad that video worked. So moving on, you can use this kind of software for all kinds of things. This is a beautiful mesh that was created. It's very intricate, and it challenges standard manufacturing techniques. And what we used was a two-dimensional bitmap to project on an image, which the customer could choose, in this case a butterfly, that would create crystal holders on the surface of this mesh. It's almost like a cloth. It's so intricate. And many companies, jewelry companies, struggle with putting on such crystal or diamond holders. They cost a lot of money. They're very time-consuming to do by hand. So this can be automated and created through a 3D printer. This is built in titanium, again on an EOS laser sintering machine, which I think is probably one of the best candidates at the moment for final-end luxury high-end goods. And once this product came off the platform, it was sliced off. This is what it looked like once the crystals were then inserted onto it later. And it really is a beautiful mesh. It's very slinky, heavy, and it's like a cloth almost, but it's all in metal. And then we went further with Cookson and EOS, who've created a gold sintering machine, and they will be progressing that into precious metals like palladium and also silver, for example. This is what came out. So beautiful. It really does challenge standard manufacturing and craftsmanship. So it begs the question, what will happen to the individual designer? What will happen as well to copyright? There are lots of questions that will arise. We can take this away from aesthetics and move it to more functional parts, scanning someone's body and having products made to fit. That's what 3D printing is all about, individualization. Moving even further, our sister company Within Technologies worked on the idea of customizing midsoles of shoes. They actually wanted to try and make the world's most comfortable high-heel shoes by testing individuals as they walked, where they placed their weight, and creating a lattice structure within a flexible material that was 3D printed that could be inserted into the shoe. And the results were very interesting. This is definitely something that could move forward into high-end footwear and sportwear. And in the past, it's not something that my company or my sister company have done, but we can see how 3D printing is used to individualize parts. This is Paralympian Michael Tuber, who is actually German. He had a prosthetic made for him. Unfortunately, he had an accident a few years earlier, which had left him without a limb. But with this manufacturing technology, he could have a one-off prosthetic made for him. And we know that prosthetics are individual to every case, and they're very expensive. But with this manufacturing technology, we make them more viable. This was created by a company called Ortima. And he ended up winning the Paralympics race, cycling race. Scanning our other parts of our body, our teeth to make dental copings, this is all possible today with sintering technology. Scanning our bodies through 3D data and using that to make medical implants. Today, we're actually seeing medical implants that are 3D printed, laser sintered in medical-grade titanium that are being approved and inserted into human patients, which is quite remarkable. Imagine that perhaps in the not-so-distant future, we would have individuals walk into a hospital, they need a replacement limb, they'd have their body scanned, and hey presto, within a number of hours, a bespoke implant is made for them. And these are some examples of spinal implants. The very intricacy that 3D printing can create means they're more porous. They can accept body matter much more easily, so they're a far more superior product. So we're all different. We engage in different ways. We want different things. And our body is all about data that relate to these things. The world is becoming more networked. We are becoming more connected, and we want to be connected to the things that we buy, the things that we use. And I believe that 3D printing is causing a revolution in mass customization in this way. Thank you very much.